Today we're going to look at a 6 marker from paper 1 explaining the differences in melting points between the allotropes of carbon. So these are graphite, diamond, fullerene and graphene, and we need to discuss the role of their structure and bonding in determining these melting points. Looking at the graph, we can clearly see that graphite, diamond and graphene have melting points which are roughly the same, and fullerene is clearly much lower. And given the nudge in the question, this is primarily to do with their structure and bonding. So this question here is testing your knowledge of giant covalent structures versus simple covalent structures. We can see that graphite, diamond and graphene have melting points of greater than 3,500 degrees C, as indicated in the graph. These allotropes are all giant covalent structures, which means that they have a large network of strong covalent bonds. This requires a large amount of energy to break the bond, so they have high melting points. On the other hand, fullerene has a much lower melting point of 300 degrees centigrade. So this compound is a simple covalent structure with weak intermolecular forces between the individual fullerene molecules. So this requires a small amount of energy to overcome the forces, so it has a low melting point. I mean, in essence, the way to answer this question was first to talk about the type of structure, either giant or simple covalent, then whether it had large networks of strong covalent bonds or weak intermolecular forces. And it's really important that you get this right. It is always strong bonds and weak forces. It's never the other way around. And finally, if we're talking about melting point or boiling point, you need to talk about energy. And so a large amount of energy to break the bonds and a small amount of energy to overcome the forces. The last point is just always refer back to the data in the question. So although in this question the 6 marks were given for the actual science, typically 1 or 2 marks are given for the data taken from the plots. So in this case, 3,500 degrees C for the giant covalent structures and 300 degrees C for the simple covalent structures.